Hello, and welcome to my YouTube channel called Statistics from A to Z, Confusing Concepts Clarified. These videos are based on content from my book of the same name, which is published by Wiley. For more information on the book and these videos, please visit statisticsfromatoz.com. This video assumes that you are familiar with the concept of the Chi-Square test statistic and its distributions. If not, please view my video on the subject. This is the fifth of six planned videos in a playlist on the subject of statistical tests. As of now, all of these except for the last one have been completed. If you want to know the latest status of the videos I have been doing, please see the videos page on my website, statisticsfromatoz.com. Here is a key to understanding this test. The Chi-Square test for the variance compares the variance calculated from the sample data to a value for the variance which we specify. It answers the question, is there a statistically significant difference between these two variances? The test can be one-sided, one-tailed, left or right, or two-sided, two-tailed. And it can be framed as a confidence interval test or a hypothesis test. The specified variance is a number that we specify. It can be, for example, a target value of a quantity or quality measurement, a historical value of a population or process variance, or an estimate of a population or process variance. If you're familiar with the F-test and the T-tests, here's a compare and contrast table which may help you understand where the Chi-Square test for the variance fits in. The F-tests and T-tests are covered in other videos. The F-test and the Chi-Square test for the variances both compare variances. The Chi-Square test compares the variance of a sample to a variance which we specify, while the F-test compares the variances of two samples from each of two different populations or processes. If you're familiar with the T-tests, it may help to know that the Chi-Square test for the variance is analogous to the one-sample T-test. Both take a sample from one population or process and compare it to a specified value for the statistic, Chi-Square or T. The T-test does this for means, while the Chi-Square test does it for the variances. The F-test, on the other hand, is analogous to the two-sample T-test. The Chi-Square test for the variance is non-parametric. It has no restrictions on the data, other than it be numeric. The F-test, on the other hand, is parametric. It only works with data that at least roughly follow a normal distribution. Here is a 6-step procedure for performing the test. Step 1. If hypothesis testing is being used, state the null hypothesis, H0. There are 3 types of hypothesis tests, and the null test is stated differently for each of them as shown here. For a two-sided hypothesis test, the null hypothesis is that the population or process sample variance equals the variance which we specified. One-sided tests can be either left-tailed or right-tailed. For a one-sided left-tailed test, the null hypothesis states that the population or process variance is greater than or equal to the specified variance. For a one-sided right-tailed test, the null hypothesis states that the population or process variance is less than or equal to the specified variance. Step 2, select a value for the significance level. Most commonly, alpha equals 0.05 is selected. Step 3, collect a sample of data of size n. Step 4, determine the degrees of freedom. For this test, degrees of freedom equals n minus 1. In step 5, calculate the critical value or values. The two-sided test would have 2 different critical values. Step 6, compare either chi-square to chi-squared criticals or compare p to alpha. The comparisons are statistically identical since alpha for the one-sided test or alpha over 2 for the two-sided tests is the cumulative probability for a critical value. The farther out along either tail, the smaller the probabilities get. If the test statistic Chi-Square, which was calculated from the sample data, is more extreme, which means farther out along a right or left tail, than a critical value, equivalently, if p is less than or equal alpha, we conclude that the probability is very small that this result is due only to chance. Thus, there is a statistically significant difference, and we reject the null hypothesis H0 between the specified variance and the variance of the population or process from which the sample was taken. If the test statistic Chi-Square is not more extreme than the critical value, equivalently p is greater than alpha, then there is not a statistically significant difference, so we fail to reject H0. The confidence interval is between the critical values. Confidence intervals for variances and standard deviations are wider than those for means because estimates of means are more accurate than estimates of variances or standard deviations. That concludes our discussion of the Chi-Square test for the variance. This has been the 5th video in a playlist on statistical tests. Coming next is a video on nonparametric tests. You can always check the videos page on my website for the latest status of videos completed and planned. If you liked this video, please remember to press the thumbs up like button on your screen below. I'll be making more videos of some or most of the 60+ concepts in the book if folks like you tell me more videos are wanted. Please subscribe to this channel to be notified when new videos are uploaded. Also, the website statisticsfromatozz.com has a listing of available and planned videos. Now, videos like this one can be very helpful, but they're not very handy when you want to quickly look up something on the job while studying or during an open book exam. For that, nothing beats a book or an e-book. You can also learn more about those on the website. I'd recommend following my blog at statisticsfromatozz.com/blog. I've got some things there that hopefully you will find interesting, like a statistics tip of the week, as well as posts showing that you are not alone if you're confused by statistics. I'll also be posting on the Facebook page, Statistics from A to Z, and on Twitter as @StatsA to Z.